Hello everyone, this is Mohammed from Python Ninja YouTube channel, and today we will highlight random secrets Numpy modules to generate random numbers in Python. So there are many methods for random number generation in Python, or there are many modules, and each module is associated with like a specific task. In Python, random number generation gives advantage in many applications. For example, it gives unpredictability in games or in Monte Carlo estimator. Later, you will understand more about Monte Carlo estimator when we like run an experiment or a code for like random number a random number of iterations just to take the mean of the like execution or the performance. Also, the random number generation is implemented using built-in Python modules. We will introduce three modules. Random module for pseudo-random number generations. We call the number R pseudo because we can it's not fully random. We can reproduce these numbers, and we will show how can we reproduce these numbers. And we have secrets module for a cryptographically robust random number generation. And we have also finally a Numpy module for array generations, associated with random number. As usual, the first thing we can do is to import random module, which is the first module we will highlight. If I want to like print more information, I can print the dir of this module, and can see what are the methods, what are the attributes inside this random, or I can use help, to help me to understand each method and how can I apply this method. The first thing we want to introduce using random module is the generation of random float number. The float is a number that is not integer, and to generate a number between a float number between 0 and 1, and in this case 1 is not included but 0 it might be generated, we use this syntax. So here I want to use directly print random, because we imported random, and inside random there is another random, and this will bring to me a float number. This float number lies between 0 and 1. I can print as many as I can. For example, I can say for underscore. Underscore is like a dummy variable. I do not need to use it, just I need to use it to run the for loop in range. I want to use, for example, range 20. Then I want to print random. Dot random. And this will print to me 20 randoms, 20 float and random float numbers, and this is for a random number or float number generation. We can like generate also float numbers, taken from like a uniform range or in a specific range when I use dot uniform, and in this case I have to insert the lower and upper bound. I want to use like generation of 20 numbers between 1 and 20, and this should be float. As you can see, these numbers are float and all numbers are between 1 and 20. Sometimes the Python can generate 1, but it cannot like generate 20. Remember, for this uniform, random.uniform or random.random, it generates float, and both numbers are taken from a like uniform distribution. In the same time, I can generate a random integer, for example, or a range of random integers. Instead of using uniform, I can use an integer, and in this case I can generate 20 integers, so it's not a float, it's integers. In the same time, I can like generate one number, but here I want to show you that we can generate a set of numbers here. So this is for a random integer. So if you want to make it like more professionally, you can, for example, start just to make it more functionally, and we have int, okay, and in end I want to use 100, and here I can place a star and I can place int, okay, just to add some functionality to your code. And we can see here we generated number between 10 and 100. Remember one thing here, that in random integers, sometimes the Python will return to you the int, okay, or what is called upper bound. To generate random integers without considering the int, which is this in the generation, you can consider rand range, okay. So we have a rand range to generate like range of numbers and excluding the upper bound, which is the int, okay. So far we highlighted random to generate float numbers. We introduced random uniform to generate like float numbers within a range, rand integer to generate integer number, and rand range to generate like integer numbers, but not including the upper bound we have. And in case if you work in statistics, in statistics we use like normal distribution, not the uniform, as what we introduced for like uniform or random method. We now have we want to introduce normal variate, for example. For normal variate, it is commonly used in statistics, okay, and the here instead of start and end we have to say we have mean and we have standard deviation, STD, and usually the random distribution like the numbers can be expressed as this form. We have a set of numbers that has 0 mean, okay, and 1 standard deviation. And I can say here we have this mean and we have this standard deviation or STD, and we will see that I have, okay, a range of numbers between like 0 and 1, and this can draw to me a normal distribution, taken from normal variate method, okay, from random module, and this is like useful in statistics, okay. Now I want to highlight a choice and a sample or sampling. And suppose we have like a list of options. So we have options like banana, okay, and we have apple, and we have pineapple, okay. What we will have, maybe we will have cherry, okay, and these are all the fruit options I have. How can I pick one sample from this list randomly? I can say choice is equal random dot choice, not the choices, a choice to select one option, okay. Remember this, and I printed choice, okay, and each time I pick like a random choice, okay. But and this is like not just for the list, but it can like be for a string. But what if I want to select more than one? I want to choose like 3 options. Instead of a choice, I can use sample, okay, and sample require additional argument here. For example, I want to select 3 samples, okay. So again, this method require additional argument, which is the number of samples, okay. So when I pass 3, it select to me 3 random options. And remember, these options are not repeatable. For example, it picks any 3 options, but it cannot like pick banana 2 times. But what if I want to pick also, for example, 2 times banana and 1 time apple? Okay, then I go from sample to choices. Okay, not the choice. The choice will return me 1. Okay, for example, let us execute this. Okay, and here we, instead of using a 3, we have to use like keyword argument. In the next tutorials, when we introduce function, you will understand what I mean of the keyword argument. And if we run this code, we can see that apple has picked 2 times, okay, but banana 1. And this is, for example, sometimes it pick the same element 3 times. So it shows pick 1 time, samples pick 3 times but different, and it shows it can pick like all options from the same items or from mixed items, okay? And suppose also you have this list of cards or cards number, and these numbers are 10. For example, I have 20, I have 30, and I have 40. Keep it as it, okay, and I have A, okay, and I have B, and then I have C. Okay, what if I want to like shuffle this list, meaning that like randomly swap the allocation of these items? In Python, there is a method, in random module, there is a method. It's called shuffle, and this is used like this form. We cannot say like shuffle, okay, equal. No, this is not used like this because it is applied in space, meaning that we apply this method to this list directly. So there is no need for variable assignment here. We use it in this form, okay? So this is the form. Don't use any variable assignment here, and you can now print cards and it will be shuffled. For example, B, it was here, it's like randomly swapping these items. Okay, so shuffle, it takes a list of items and like shuffle this, but we use this syntax to shuffle this list. Now, why I say this pseudo-random number generation? Because we can reproduce the same random number. Okay, so random number is not fixed here. Okay, let's see what I mean. If I want, for example, print random.rand integer, I want this random integer to be from 1 to 100. Okay, look at this screen. So we printed number here and we printed another number here randomly, but I can like regenerate or reproduce the same number. Okay, so it's not like fully random, it's pseudo random. How can I do that? I can use this syntax, random.seed. Seed is a method that fixes the point, okay, or the state of random generation. Okay, so we fixed the generation from the seed or from the state 42. Then I can produce the same number each time. So we have 82 each time. At each run, we have 82. But when I delete this line, I will have different number each time. Okay, so it's like pseudo because we can generate or reproduce the same number using the seed function. Okay, and that's apply for every random methods we introduce. This is my recommendation. Whenever you import random, you can fix the seed. Fixing seed is very important for reducibility and to have the same result each time. Okay. Now that's for random. We highlighted random.random. We highlighted random.uniform, where random integers, choices, samples, and all samples. And all are introduced together also with normal variate method. Now, for the random number, we can reproduce them. Okay, so random module, we can by using random module, we can reproduce number by fixing seed. But for like more robust random number generation or reproducible or a number, we don't use random, and we use for stronger or more secret number generation, we use secret module, which is secrets. We can say import secrets. Okay, and in secrets we want to introduce only 2 methods and from this we have the dot random below. I generate a random number under 100, okay, below 100, and by running this I can generate each time, okay, like a cryptographically or more robust or more secure number than the random number generation. We cannot like fix seed, or we cannot reproduce this number again. And there is also another method which is called rand bit, in which I can generate a number of length 100 bits, okay, like this, okay, and this can be like randomly each time generated. I can use, for example, 8 bits, it will generate this number, and this module is much more robust than the random module. However, random module is like used like in every like application when there is game, and it's like commonly used. But this secrets module is more robust and more secure, and we highlighted now rand below to generate a random integer number below 100 or one like a specific range. We also highlighted rand bits to generate like a number with fixed length of bits. The same thing here for choice. For example, if I say my name is Muhammad, okay, and I can say the same, print secrets.choice, okay, secrets.choice. This is the only method. I can pick like a random letter from my name, okay, here that is like a string, not a list, and we every time pick like a random number, okay, and more robustly because we cannot we are unable to reproduce this. Finally, I want to highlight Numpy module. If you work in like an array, okay, so you, or in matrices, so you must likely use Numpy, and you have to use Numpy. I will give separate tutorial in in the machine learning series later, but I just want to give a brief introduction. If you use the Numpy for the first time, please go to the terminal, this in the bottom, and write this there, install, okay, Numpy, okay, in case if Numpy is not installed to your machine, and it will be like installed because I already installed this Numpy before, and it will show to me that requirements already satisfied. Now, what we can do with the Numpy module, I can say import Numpy and nb, and this is the most common like form that is used in the development community. We use onboard Numpy as nb. You can use whatever you want as num, but this is the common convention. Please follow the convention that is used by the common society. I can generate a vector of 3 elements, 3 float elements. In this case, I can say nb.random, okay, you have to say nb.random.rand, and I open like this bracket, and I will see here I have a vector of 3 float values, okay, and every time these values will be changed. I can generate 2D array just by opening by adding this comma and another. For example, I want to have 3 rows and 5 columns. It will be here 3 rows, the first row, the second row, the third row, and because it is like 2-dimensional array, we will have outer, okay, square brackets, and we can generate also these are a float number, but we can generate integer, okay, or random integer. So I can say generate random.rand random.rand int or .rand integer, but this will give me 1 random. I work in matrices. I want to generate 10 numbers. This will be like this, okay. We have 10 numbers between 3 and 5, okay. I can take it between 3 and 50, and this is a vector, okay. But if I need an array, I open another like rounded bracket. I can say I need 10 by 10, and I run this. It will give me like two-dimensional array of 10 by 10 length. Now, sorry, size. Now we can also like instead of using like a random generator or inside the Numpy to generate number, I can like design my own array. So, for example, this array will be like nb.array. I can use .array. Then what I can do, I can open the out. If I want to use a vector, I can say like this. If I want to generate only vector, I can generate this and print array. Okay, now this is only vector, but if I need to generate 2D, I have to have another outer bracket, and I open like 20, 30, 40. Then I will have two-dimensional array. These numbers are pseudo if I use like this number. Let us to see. My array is nb.rand integer, nb.random.rand integer. Sorry, rand integer. Okay. This should be like I want to generate between 0 and 10. Okay, and we want to consider two-dimensional array 10 and 20, and we will have this array. Okay, this array is generated using like rand integer generator, and we can reproduce this array. So it is like a pseudo array generator, and we can also shuffle this array. For example, I can say nb dot random dot shuffle like this dot shuffle. I hope it is like correct in the term of spelling. Yeah, every time I see here like every number has been shuffled or changed. Okay, and by using random.shuffle, I can shuffle the matrix or the 2D array, and I can generate the same array. Okay, I can generate the same array here. So we can we generated the matrix. Before generating the matrix, I can say nb.random .seed. Okay, the same as what we use in the random module. I can say 42, and I print array. Okay, so we can have the same array each time, meaning that it's like a pseudo random matrix or array generation using Numpy, because we can reproduce the matrix or the array. So we learn together in this tutorial for Numpy how can I generate like a float vector, a float array, integer, a float integer vector, integer array. We can design our own array. We can shuffle our own matrices or arrays. We can fix the seed. The same also for secrets, but secrets module that doesn't like work with a seed. And that's for today's tutorial, guys. Thank you, and see you next tutorials. We will highlight some exercises.